Okay, everybody, welcome to another video. This one is going to be supporting you on correcting your Advanced Math Semester 1 final for Math 6.3 and Math 7.2. So this is just a review of a lot of the concepts that we've gone over this first semester, and you can use this as an answer document, as a support, however you need to use it. Okay, so let's go through problems with you guys. So this is your answer key, and let's go through and do it. First section here is just on conversion practice, so basically portion webs. So it's got a missing element, either a fraction, decimal, percent. You got to fill it in. So this first one, 7 1/5 is equal to 720% is equal to what? So obviously 7 1/5 is 720% because basically 1/5 is equivalent to 20 out of 100. Remember, percent is per 100, so this is the same as really technically 720 out of 100. That's what this is. And so 7 1/5 is the same thing, right? Because this is the same as 7, and if you times top and bottom by 20, you're going to get 20 over 100, right? Which is, of course, 720 out of 100. So these are equivalent. So we're looking for the decimal value that's equivalent to this, right? And the nice thing is that when you have it as a percent, it's already basically a decimal, because all you have to do is recognize the fact that you have this percent sign at the end, and percent means per 100, so it's really 720 over 100. And that means that it's going to be 720 ending in the hundredths place, right? Or 720 hundredths. So technically what that means is that if you were to think about your place values, right, it's going to end in the hundredths place, which is right there, and it's 720. So it's going to be 7.2. And logically, it makes sense too, because 700% is going to be 7, because every 100% is one whole. And then the 20% is 0.2, right? So 7.2. Another little shortcut you can use is if you want to change this percent to a decimal, you just drop the percent sign and move it to the left, right? And if you want to make it into a percent from a decimal, you just basically move the percent, the decimal to the right, and then add the percent sign, right? That's another little shortcut trick. Okay, so either way, this is the idea, and it's going to be 7.2. For this one, it's 93.93 repeating percent, or 0.93 repeating. Remember, when you have a repeating pattern like this, the repeating element, place value where it ends, is going to be a big key to let you know kind of what to put as your denominator for the fraction. So in this case, you can see it's 93 repeating in the hundredths place. So instead of 100, you're going to make it over 99, okay? So anytime you have a repeating element, if it ends in the hundredths place, you put over 99. If it ends in the tenths place, you put it over 9. If it ends in the thousandths place, you put over 999. And so in this case, it ends in the hundredths place. You're going to put 99 on bottom, and then 93 goes on top, right? And then from there, you're just going to simplify it, right? So it's going to be 93 over 99. And then you can divide top and bottom by 3. And when you do that, you're going to get 31 over 33. And that's going to be as far as you can go. So that will be the simplest form fraction. So that's your answer for this one. And that's your answer over here for this one. It's pretty easy, right? Let me just box those for you and take off the extra stuff. For the next one here, you got 11/40 is equal to some value is equal to 0.275. If you are given the decimal, it's just really easy to make it a percent. You just take this decimal, which is really 0.275 over 1, and you want it to be over 100 to make it a percent, right? So you're going to times top and bottom by 100 and get your equivalent ratio, which in this case would be 27.5 out of 100, right? So the percent is just 27.5%. So this should just be 27.5%. The shortcut for this is that you're going to just take the percent sign, or sorry, the decimal I should say, move it 2 to the right, and then add the percent sign. So when you're going from a decimal to a percent, what you're going to matters. Move the decimal place 2 to the right. Percent has an R in it, right? Percent. And if you're going from a percent to a decimal has an L in it, just drop the percent sign and move it to the left, and vice versa. So there's your answer for number 3. Okay, cool. Let's talk about these ones down here. It says simplify the following expressions. So in these problems here, you're basically doing some order of operations. I like you guys to circle your terms or box your terms first. So that's what I'm going to do. So I'm going to go through and I'm going to look at my terms as separated by addition and subtraction outside of parentheses. So this is 7 times -8. And then this is 12 to the second divided by 3. And those two things are being added together. Okay. So in this particular case, we're going to use PEMDAS within each of the terms. This is 7 times -8, which is -56. The addition is the operation between them. And then over here on the right-hand side, we got 12 to the second power, which is 144. We do the exponent first before we divide. And then you have divided by 3. So 144 divided by 3. Just do that off to the side, whatever that's worth. 3 goes into 14 4 times, which is 12. There's 2 left over. 3 goes into 24 8 times. Okay, so that's going to go perfectly, nothing left over. So that means that 144 divided by 3 actually has the value of 48. So this is going to now be negative 56 and then plus 48. Let me change the color to make it pretty. It's going to be negative 56 and then plus the value of 48. Who's going to win that battle, positive or negative? Since they're going different directions, right, it's going to subtract. Who's going to win? The negative. By how much? What's 56 take away 48? You're going to get 8. So it's going to be negative 8 as your answer. That's what you should have for number 4. Okay. For this one, number 5, same idea. You're just going to go through and you're going to identify your terms. The terms in this case happen to be separated by addition and subtraction outside of parentheses. In this case, we're going to have negative 6 to the second power divided by 2. That's one term. And then you're going to have another term, which is 180 divided by 2 to the third. All right? Work within each of those terms and then combine them with the operation between them. So in this particular case, you have the exponents happening first. Remember, the exponent only applies directly to what's touching. That negative is not included in the exponent. If they wanted it to be included, they would have put a parentheses around it like this and raised the whole parentheses to that power. They don't want it to be included, so they just put it in front like that. Okay, so that's a negative result. Okay, and 6 to the second power is 6 times 6, which is 36. And then you're going to divide that value by 2. So ultimately, this whole thing still stays negative because the negative divided by positive is negative, and 36 divided by 2 is 18. So you're going to end up with negative 18 for that first part of it. Let me close this. For that first part of it, negative 18. That's your first term. The operation between them is the subtraction, and then we got to figure out what this blue value is, the second term. Once again, we'll do the exponents before we do division. All right, this is 180 divided by whatever 2 to the third is. That's 180 divided by 2 times 2 times 2, which is 8. So it's 180 divided by 8. When you're doing 180 divided by 8, just do that off to the side if you need to. 180 divided by 8. 8 goes into 18 twice, which is 16 with 2 left over. 8 goes into 20, looks like 2 times, 16 with 4 left over. And 8 goes into 45 times. So it's going to be 22.5. So the answer here is that we're going to have that value for the blue term. It's going to be negative 18, take away 22.5. Now, taking away 22.5, as you guys know, is the same as adding up negative 22.5. So these are just two negatives that are going to be added together. And that means they're going to get more negative. So we're going to get negative. And then 18 plus 22 is 40. So this is going to be 40.5. Negative 40.5. If you were going to line them up the old-fashioned way, just make sure you line your decimals up right. So it'd be 18.0 plus 22.5. 18.0 plus 22.5, and then when you add it together, you get that very same answer that I just described. Okay, see, there you go. On this one here, same idea as before. We're going to look for our terms. We're going to circle our terms and work within each term. So in this particular case, when we're going through it, you have the first term, which is 2 times the quantity of negative 25 divided by 10. All of that's one term. And then you have the second term, which happens to be 6 times the quantity of negative 3 to the second power. We're going to use PEMDAS within each of those terms and work through the problem. So in this case, we have 2 times negative 25 divided by 10. You multiply and divide from left to right. So this is going to be 2 times negative 25, which is negative 50. And then you're going to divide that by 10. Negative 50 divided by 10 is negative 5. So the value of this pink term is negative 5. And then you're going to add to that whatever this blue thing is worth. The exponent only applies directly to what it's touching. So in this particular case, that's applying to just the parentheses there, including the negative. That means this is negative 3 times negative 3, which is 9. So this is the same as 6 times 9. And as you guys know, 6 times 9 is 54. So you got negative 5 plus 54. Who's going to win, positive or negative? The positive, by how much? Take away the losing side. So this is the same as 54, take away 5, which happens to be 49. And that is your answer. If you got it right, good job. If not, hopefully it feels more comfortable now. Let's talk about the next set of problems here when we're working with fractions and mixed numbers and decimals, basically all kinds of rational numbers. So in this case, we're going to be adding and subtracting them for the first row here, and then down here we're multiplying and dividing them. Okay, basically, can you do operations with rational numbers? The way that I would do this first problem is I would start by just rewriting it with a common denominator and change all my subtraction to addition. So for me, when I'm looking at this, what I'm actually saying is 9 and 3/6 plus the opposite of negative 1 and 1/3. So that's positive 1 and not thirds, but 6. We'll make it all 6 on the bottom. That's going to be 3 times 2, 1 times 2. So that's going to be 1 and 2/6. So it's really 9 and 3/6 plus 1 and 2/6, and then plus 2 and 5/6. Now you've got it all in sixths. We're all the same size pieces. Now let's combine our whole, combine our parts, and simplify. So it's 9 plus 1 plus 2. That's going to be 11 plus 1, which is 12. So you got 12 whole values. And then 3/6 plus 2/6 plus 5/6 is going to be 10/6. How many times does 6 go into 10? That goes in one whole time. So add 1 to 12, we get 13. You get 13, and how many 6 are remaining? 10 take away 6 is 4. So we're looking at 13 and 4/6. And then you want to simplify the 4/6 to 2/3 by dividing top and bottom by 2. So the final answer that you should have here is 13 and 2/3. If you got that, you got it right. Good job. Okay. For the next one here, we're going to start by looking for a common denominator. I got halves, eighths, and fourths. Let's make them all into eighths. I'm going to make sure that I have a clear understanding of what I'm doing. So I'm going to make sure I change all my subtraction to addition real quick. So we have basically negative 3 and how many eighths? 4/8, because times top and bottom by 4. Then I've got take away or plus negative 2 and 3/8. Fair enough. And then you got plus negative, and then 5 and how many eighths here? So times top and bottom by 2, you're going to get 6/8. Okay. Now you've got an equivalent ratio for everything that's a fractional part out of 8, and you've got the whole values. I did rewrite it all as addition. I think we're at the point where we don't necessarily always need to do that, but it was just pretty convenient and easy to do it right now, so I did it. In this case, we're going to combine all these negatives. They're all negative things getting added together, so they're all going to get more negative, which means the answer is going to be negative, which is really the sum of all this stuff. Okay, so what is 3 plus 2 plus 5? That's going to be 7 plus 3, which is 10. And that was really ugly. Let's fix that. There we go. And then you got 4/8 plus 3/8 plus 6/8. That's 10/8. That's 10/8 plus 3/8, which is 13/8. So you're going to end up with negative 10 and 13/8. How many times does 8 go into 13? One time. That's really negative 11. And how many are extra left over? 5. So you're looking at negative 11 and 5/8 as your answer. And that's what you should have. Okay. For the next problem, you've got decimals. In this situation, I would just do true sign kind of. You could change it to addition, say negative 4.5 plus the opposite of negative 12.05 plus positive 0.6. So really it'd be negative 4.5 plus 12.05 plus 0.6. But I'm just going to do this the shortcut. So the other one here, I rewrote it, the subtraction is addition. Remember, subtraction is the same as adding the opposite. On this one, I'm just going to recognize that the one sign in front, or that is in front of everything on the left-hand side, is its true direction, and everything's being added together. Okay? It's a shortcut for what we did over here. Ultimately, in this situation, I would recommend a scoreboard because of the decimals. It's nice to line up the decimals. So in this case, I got 4.5 on the negative side. I've got 12.05 on the negative side. And I've got 0.6 on the negative side. I'm actually 0.6 on the positive side. Oh, and the 12.05 is on the positive side. See, I was almost sloppy about that. Let me try to fix that for you guys. Sorry, I was being a little sloppy. So yeah, that's a negative 4.5. Good. And then we have a positive 12.05. And we have a positive 0.6. So line up your decimals. It should look like that. Add up your total positive. You're going to get 12.65 total positives. And who's going to win, positive or negative? The positive is going to win, so we know the answer is going to be, in fact, a positive. Put a positive box. And then take away the losing side. So take away 4.50 from that, and you guys will see the answer. 5 take away 0 is 5. 6 take away 5 is 1. Bring your decimal down. 2 take away 4 can't do it. Borrow. And so what you get is you get 12 take away 4, which is 8. So you're looking at 8.15. And it just actually is 8.15 plus 4.5 equal to 12.65. And yes, it is. So it should work just fine. This is going to be a positive 8.15 as your answer. For this one here, number 10, where you're multiplying and dividing, just make sure that the first step you do is that you change your division to multiplication. Remember, dividing fractions is easy as pi. Just flip the second and multiply. So this becomes 5 over 11 times negative 22 over 90, and then times the reciprocal of 1/5, which is 5 over 1. Okay. Once you've done that, then you can look to cancel and resolve your sign. So for me, the first thing I would do is I resolve my sign so I can ignore my sign. I've got one negative factor amongst the three things that are being multiplied together, which means I'm going to have an odd number of negatives, which means it's going to be a negative answer. Remember, if you have an odd number of negatives, it's a negative answer. If you have an even number of negative factors, it's going to be a positive answer. So in this case, the answer is going to be negative. So I know that the answer here is going to be, in fact, a negative value. All right. And then I can look to dance a little bit, do a little canceling. So when I'm looking at this, I'm seeing that the 11 and the 22 can cancel the 2 and 1 because 22 divided by 11 is 2 and 11 divided by 11 is 1. I can see that the 5 and the 90 can both be divided by 5. 5 divided by 5 is 1, and then 90 divided by 5. And well, 50 is going to be 10, and 40 is going to be 8. So we're looking at 18. And then I notice that I've got this 2 on top and the 18 on bottom. So I can cancel the 2 to make it a 1 and cancel the 18 to make it a 9 because 2 divided by 2 is 1 and 18 divided by 2 is 9. So ultimately, I've done all the canceling that I can do. Then just multiply across the top, multiply across the bottom. So 1 times 1 times 5, that's 5. And then 1 times 9 times 1 is just 9. So you're really looking at negative 5/9. So if you want to put that into the answer document, that would be the best way to put it in, negative 5/9. For this one here, you're going to go through a similar process. Dividing fractions is as easy as apply, just flip the second and multiply. Since you're dividing by this fraction over here on the right, you're going to flip that one right, but you don't need to worry about changing the mixed number into an improper fraction. You can leave it, I think, at the moment as it is. But when you do the multiplication, you're going to want to change it. So maybe we should just change it right now. So 3 times 8 is 24, plus 7 is going to be 31. So you're looking at 31/8, and you're going to divide that by negative 27/62, which is the same as multiplying it by the reciprocal of that. So you're going to flip it top to bottom. You're going to get negative 62 all over 27. Okay. Now, when you do a positive times a negative, it's going to be a negative answer. So we know the answer here is, in fact, going to be a negative value. And then just look to dance and see what happens. So I'm looking to see if there's anything I can cancel out. It looks to me like that 31 and the 62 is kind of like a trick. Like you're thinking, 31 cancels out the 62, but it doesn't because you can't cancel across division. You can only cancel across multiplication. So that was more like a trick or a ploy. So it looks like there is a situation, though, where I can cancel out the 8 and the 62 because both 8 and 62 are multiples of 2 for sure. So that becomes 4 over here because 8 divided by 2 is 4. And this becomes 31 because 62 divided by 2 is 31. All right. And let's see, is there anything else here that I can cancel? Doesn't look like there's anything else to cancel because there's 31s on top and there's a 427 on bottom. There's nothing else that can cancel as far as I can see. So in this case, it's just kind of annoying. You're going to have to just multiply it together and see what happens. So I'm just going to grab a calculator to make things a little easier for us. So 31 times 31. We're going to get the answer of 961. And then 4 times 27 is going to be the bottom, which is 4 times 27, which is 108, okay? And then if I ask myself how many times does 108 go into 961, if it was 9, it would be too big, so it's probably 8. So let's do 108 times 8 and see what it comes out to be, 864. So it's probably going to be negative 8 and something. And we know that that's 864, so let's take it away from 961. So you got 961, take away 864. 961, take away the 864, which is the eight values of 108. And you'll be left with 97. So it's going to be 97 on top and 108 on bottom. So this is going to be negative 8 and 97 108ths. So if this was the test, you put it in like that. You'd have negative 8 and then a space and then 97/108. That would be the best way to put it in. Or you could put it in as negative space 961 over 108. That would also be fine. You can't simplify it, so that is the answer, and that's as far as you can go. For this one over here, we got our decimals. So let's work with our decimals. You've got a negative divided by a negative. Resolve your sign first. That's going to be a positive answer. So put a positive box or leave the box blank with no sign in it. Either way, it's positive. And then you're going to do the 561 thousandths. That's going to go inside. And then you've got your 0.003 on the outside. All right. And you're dividing by a decimal, so we got to change that decimal into a whole value. So we're going to move it 3 to the right on the outside and 3 to the right on the inside, and then bring it up. So really it's the same as saying 3 into 561. Those are identical statements, basically. And so 3 goes into 5 one time with 2 left over. 3 goes into 26 8 times with 2 left over. And 3 goes into 21 7 times with nothing left over. So this is going to be positive 187. And that's what you should have as your answer. All right, when you get down to number 13 here, you're basically simplifying and evaluating. So the first thing you do is simplify it. Then once you've simplified it and got your simplest form, then you're going to evaluate. So let's distribute combine like terms and see what happens. In this case, you have 7 times the quantity of 2x, 7 times negative 5. That's going to be 14x minus 35 plus 2y minus 9 plus y. You're going to want to make sure that you combine your like terms carefully. So x's with x's, y's with y's, numbers with numbers. There's no other x's, so 14x just stays 14x. There are some other y's, though. You got 2y and then one more y. That ends up being 3y, so plus 3y. And then you've got your constants, which also can be combined here. You've got negative 35 and you've got negative 9. So that's going to be negative plus more negative gets more negative. It's going to be negative 44, okay, because 9 plus 35 is 44. Ultimately, this is what we call the simplest form of your algebraic expression. And then you can plug in and evaluate when x is 8 and y is negative 3. So when you're plugging in, you get this. You'd say, all right, 14 times x, which is negative 8, plus 3 times y, which is negative 3, minus 44. You multiply before you add or subtract, so it's going to be 14 times negative 8. That's going to be negative, and then 80 plus 32, which is going to be 112. And then you're going to do this one, which is going to be plus 3 times negative 3, which is going to be negative 9. So you're going to take away 9 from that. Then you got to take away the 44. Notice that all these are negative. In other words, they're all being added together, and they're going to get more and more negative. Because remember, negative 112 minus 9 minus 44 is exactly the same as negative 112 plus negative 9 plus negative 44. Remember, to change subtraction to addition, you just change what's being subtracted to its opposite. Same idea. So these are all being added together. They're all going in the negative direction, and it's going to be more of a negative answer, right? So when we put this together, we're going to get a negative answer. What's 112 plus 44? Well, 112 plus 4 is going to be 116, plus 40 more is going to be 156. And then 156 plus 9 is going to be saying it's 156 plus 10, take away 1. So that's 166 take away 1, which is 165. So you're going to end up with negative 165 as your answer for this problem. And I'm going to check that on a calculator just because I'm a bit tired. I want to make sure I don't make a silly mistake. So 14 times 8 where's that? Equals, that's 112, good. And then we know that 3 and 3 is 9, that's no problem. And the 44 is obviously 44, so plus 44 and then plus 9 should be exactly what I thought. Yep. Even though I'm tired, it worked out perfectly. Good job, me. Let's do the next one. This time you are distributing a negative through the parentheses. Make sure you distribute first, then combine like terms. So in this case, you're distributing this negative 3 through the parentheses. Make sure you multiply through all the terms inside, including their signs. So what you're going to end up with after you do your distribution is this. Negative 3 times 8x is negative 24x's. Negative 3 times negative 2y is positive 6y. Then you got plus y and then minus 7 that come along for the ride. Ultimately, at this point, the next thing you're going to do is you're going to combine your like terms. You've got negative 24x's, you've got positive 6y's, you got another y, and then you got negative 7. The only thing that can be combined there is the 6y and the 1y. So this becomes negative 24x plus not 6y, but 7y, and then minus 7. And that should be boxed as your answer. Okay, so that is your answer. That was really funny. Fix that. All right, perfect. There we go. And then once you have that, you're going to plug in and evaluate when x is equal to 8 and y is equal to negative 3. So in this case, you're going to get negative 24 times the quantity of x plus 7 times the quantity of y minus 7. You're going to multiply before you add or subtract. So you end up getting 8 times 20 is 160. 8 times 4 is 32. 160 plus 32 is 192. So you get negative 192. 7 times negative 3 is negative 21. And then take away the 7. Once again, all of this is negatives, all being added together. It's going to stay negative because it's the same as negative 192 plus negative 21 plus negative 7. And so you're going to put the negative value here. 192 plus 28, basically, right? So 28, let's do the 8 first. You get to 200 plus the 20. So this is going to be 220. So the answer here is going to be negative 220. That's it. Over here on this one, you're going to, once again, distribute. So this time you're distributing twice. You got 4 times the quantity of 8x, 4 times the quantity of 2y. then you also have, over on the other side, you've got negative 3 times the quantity of x and negative 3 times the quantity of negative 7y. Let's do that and see what happens. So when we are distributing there, what's going to happen is we're going to get 4 times 8x, which is 32x, 4 times 2y, which is 8y. You're going to get negative 3 times x, which is negative 3x, and you're going to get negative 3 times negative 7y, which is positive 21y. Once you've got all your x's and your y's, combine your like terms, you're going to see that you got 32 x's, take away 3 x's, which leaves you with a total of 29 x's. And then you've got a situation where you have 8y and then plus 21y, which really leaves you with a plus 29y's. So this is a funny little one. It's 29x plus 29y, which is pretty hilarious. You could rewrite that if you wanted to using distributive property in reverse. You could factor out the 29 and say that that was equivalent to, if you so choose, you could say it's equivalent to 29 times the quantity of x plus y. This is the same thing. I don't know which one's easier to plug into. I think it's probably easier to plug into this one. So I'm going to plug into this one. So that's 8 plus negative 3, right? So it's going to be 29 times the quantity of 8 plus negative 3. And that is basically going to be 5. So it's really just going to be 29 times 5. And what is 29 times 5? Well, it's 5 times 30, take away 5. 5 times 30 is going to be 150, take away 5. So it'll be 150, take away 5, which is going to be 145. So your final answer here for this problem is going to be 145. And if you got that right, you got it right. Good job. I'm going to stop there, and I'll do the second part after this.